Hello students. Hello and welcome to this video. In this video, we will solve question number 231 to 240. That is here and here. So the link to download the PDF will be in description. I will show you how you can download updated copies of the PDF from my website. As well as at the end, I will have a request for you to join the question answer website where you can come and ask questions or answer questions. So with that out of the way, let's get started. Question 231 says that find the quotient of x to the power 4 in the expansion of 1 plus x squared to the power 3. So general term is given by 3 factorial upon a factorial times b factorial times c factorial 1 to the power a x to the power b times x to the power 2c, where a plus b plus c is 3. Now quotient of x4 is b plus 2c. Now if you look carefully, b could be 2. So if b is 2, c is 1, making a 0. The second option we can have is b is equal to 0, that is c is equal to 2, and if c is equal to 2, then a would be 0, right? So, yeah, the total of this would be how much? A plus b plus 2c. If you see a plus b plus 2c, if b plus 2 plus a plus b plus 2c can be 4. So if c is 2, a would be 0 here. It would be 0. So the quotient of x to the power 4 is 3 factorial upon 2 factorial plus 3 factorial upon 2 factorial. That is 6. This looks like a calculation mistake here. Okay. Question 232 says that find the quotient of x to the power 10 in 1 plus x squared plus x cubed plus x to the power 4 plus x to the power 5 whole to the power 3. So the general term is given by 3 factorial upon a factorial times b factorial times c factorial times d factorial times e factorial times f factorial multiplied by this is 1, right? It is written as 7 here. Okay, we will take it as 7. So 7 to the power a, it doesn't matter whether it is 7 to the power a or 1 to the power a. The concept is important. So we have x to the power b, x to the power 2c, x to the power 3d, 4e, and 4f. So a plus b plus c plus d plus e plus f will be equal to 3. And b plus 2c plus 3d plus 4e plus 5f is equal to 10. Now, if f is equal to 2, a is equal to 1, making b, c, d is equal to 0. So if f is, so we have to find the quotient of x to the power 10. So if f is equal to 2, that is 10 will be from here. So a could be 1 here. Okay, this is constant term to the power that. So b, c, d, e is equal to 0 is one solution. If f is equal to 1, then b is equal to 1, a is equal to 1 is another solution, making a, c, d equal to 0. C is equal to d 1, d is equal to 1 is another solution, making a, b, e 0, and c is equal to 1, e is equal to 2, then a is equal to b is equal to d is equal to f is equal to 0. And d is equal to 2, e is equal to 1, then a is equal to b is equal to c is equal to f is equal to 0 are two other solutions. So the total quotient is 39. So there might be calculation mistake in this. So the general idea, you understand that we have to find by trial and error these equations by setting that x quotient to the power of 10. Question 233 says that find the quotient of x to the power 7 and 1 plus 3x minus 2x cubed whole to the power 10. So here the general term would be 10 factorial upon a factorial times b factorial times c factorial 1 to the power 8, 3x to the power b minus 2x cubed to the power c, where a plus b plus c is 10. Now for quotient of x to the power 7, we have b plus 3c is equal to 7. If b is equal to 1, c is equal to 2, making a is equal to 7. If b is equal to 4, and c is equal to 1, then a would be 5. Okay, so let's 4 and 1, so A would be 5. If B is equal to 7, then C is equal to 0, making A is equal to 3. So this would be the final quotient, that is 62,640. Question 234 says that find the quotient of x to the power 3, y to the power 4, z to the power 5, and xy plus yz plus zx to the power 6. So similar problem, we'll have the general term as 6 factorial upon a factorial times b factorial times c factorial, xy to the power a, yz to the power b, zx to the power c. So a plus b plus c is equal to 6, and we have x to the power 3, y to the power 4, z to the power 5. So a plus c is equal to 3, a plus b is equal to 4, b plus c is equal to 5. So b minus c is equal to 1, c minus a is equal to 1, b minus a is equal to 2. So a is equal to 1, b is equal to 3, c is equal to 2 is the solution. So the quotient is 6 factorial upon 1 factorial times 3 factorial times 2 factorial, that is 60. Question 235 says that find the greatest quotient in wxyz to the power 15. The quotient will be greatest in maximum number of terms will have equal power, which is 4 and 3 for 3 terms and 3 for the 4th term. So the greatest quotient is 15 factorial divided by 3 factorial upon 4 factorial cube. Question 236 says that find the number of terms in a plus b plus c plus d whole to the power 100. So we have solved one such problem, that is 230. So solving like 230, we will have the number of terms would be 100 plus 5 minus 1, c 100, that is 104, c 4. So we solve it like question 230, like this problem, okay? Question 237 says that if mod of x less than 1, show that 1 plus x to the power minus 2 is equal to 1 plus 2x plus 3x squared plus 4x cubed up to infinity. We know that if n is a negative integer or a fraction and mod x less than 1, 1 plus x to the power n is equal to 1 plus n upon 1 factorial times x plus n times n minus 1 upon 2 factorial x square and so on. So we put x is equal to minus x and minus 2, n is equal to minus 2. So when you do that, you will arrive at 1 plus 2x plus 3x square plus 4x cubed up to infinity. Question 238 says that find AB so that the quotient of x to the power n in the expansion of a plus b x upon 1 plus x square may be 2n plus 1, and hence find the sum of the series 1 plus 3 times half plus 5 times half square and so on. So this is our given series, which would be equal to a plus bx times 1 plus 2x plus 3x square plus 4x cubed and so on up to n x to the power n minus 1 and plus 1 to the times x to the power n. Now quotient of xn is nb plus n plus 1 times a. That is a plus b times n plus a, given that this is equal to 2n plus 1. Equating the quotient a plus b is equal to 2, a is equal to 1. So b is equal to 1. Now we substitute this back, we have 1 plus x upon 1 minus x square is equal to 1 plus x times 1 plus 2x plus 3x square plus 4x cubed and so on, which is equal to 1 plus 3x plus 5x plus 7x cubed and so on. Now we put x is equal to half, we get 1 plus 3 times 1 upon 2 plus 5 times 1 upon 2 square, and then we can evaluate this for x is equal to half. Question 239 says that sum the series 1 plus 1 upon 3 plus 1 times 3 times 5 upon 3 times 6 times 9, so on up to infinity. So we know that 1 plus x to the power n is equal to 1 plus n upon 1 factorial plus times x plus n times n minus 1 upon 2 factorial times x square and so on up to infinity. We compare the first two terms, nx is equal to 1 upon 3, n times n minus 1 times x square upon 2 factorial is equal to 1 into 3 upon 3 into 6. This 5 upon 9 is in the third term. There is a typing mistake in this one, big one. I'll fix 239. So once we have that, we solve for n and x with two equations. We get n is equal to minus half, x is equal to minus 2 by 3. Hence, the sum of given series is 1 plus x to the power n is equal to 1 minus 2 upon 3 to the power minus half is equal to root 3. There is a typing mistake in this one. This 5 by 9 will not be here. Okay. Question 240 says that if mod x less than 1, show that 1 minus x to the power minus 1 is equal to 1 plus x square plus x cube up to infinity. So the series we already know, we put x equal to minus x and equal to minus 1, and we directly arrive at the answer by evaluating this. So with this, we come to the end of 240 problems. Now I'll show you my website. So this is ashtavakra.org. I don't know why it is taking so long. Yeah. So second one is algebra, third is trigonometry, fourth is geometry, coordinate geometry. You can download the PDFs and study. Note that downloaded PDF will not have date, so you add this date here into your downloaded PDF, and once in 15 or 30 days, you come back and see which one is updated, and if a PDF is updated, you download the PDF and add the date again. Coordinate geometry is also available in HTML, which uses MathML for mathematical formula. So the best browser you can use is Firefox. Firefox has best HTML support. So I'm working on conic sections. I'll show you. So some questions are done, and a lot of problems are there to be added. And then we will have miscellaneous chapter. So right now 42 questions are added. So I will slowly update these questions and you can read it. Also, if you want to ask the questions or if you can answer, you can come and join pundika.astro.org. We have tags created for algebra, calculus, geometry, coordinate geometry, probability, trigonometry, and mathematics. So join the community and let's grow together. Let's learn from each other. So you'll need to make a login, and once you have made a login, you can come ahead and ask questions and answers. So with this, I will end this video here, and we will meet again tomorrow with 10 more problems. This typing mistake is a big one. I will fix this. There might not be a typing mistake. There might be a typing mistake here. 1.5 upon 3.9 could be the case. 6.9, 1.5 upon 6.9, 3 can be done. So I don't want to get into calculation right now. So I'll see question 239 and I'll fix it. Okay. So with this, I'll end this video here. I hope that you have enjoyed the video and found it useful. So we will meet again after tomorrow with 10 more problems. Till then, stay curious, keep learning, and most importantly, enjoy.